Welcome back. Email sending, video processing, and report generation. API calls that takes minutes. These are not edge cases, they are everyday challenges. Today we are solving them with FastAPI plus Celery. User will thank you. Your server will thank you. Today we are going to build a project using FastAPI, the Python framework with Redis plus Celery. As you see in this diagram, we are going to use the Celery, Redis, FastAPI, the FastAPI service which will handle the task queue, and all these services inside Docker. Let me explain you how these are working. The first one is FastAPI. The FastAPI have the role of API gateway. This FastAPI API gateway receives requests, send tasks to queue. This FastAPI gateway, this will act as a API gateway which will receives the requests and then send tasks to queue. And then the Redis, this is nothing but a message broker. This message broker stores tasks in queue, shares results, and then the Celery, this is a worker pool, picks tasks from Redis, executes them. The Celery is acting as a worker pool which picks the task from Redis and execute them. And then task queue, the buffer. The task queue is a buffer which holds pending tasks, prevents data loss. And Docker, Docker is a orchestration runs all services consistently. The FastAPI services handles incoming HTTP requests, serve as the entry point for the users or clients, submits tasks to Celery, and provides status check endpoints. It acts as the front-end API layer that keeps responses fast by offloading heavy work. And then the Celery, it manages the asynchronous background tasks. It receives tasks from FastAPI, queues them, distributes them to workers, execute long-running process, and track task status. Celery is the distributed task execution engine. The Redis serve as the message broker between FastAPI and Celery. The Redis will be working as a message broker between Celery and FastAPI. It stores task message in a queue, manages task results, and handles communication. This Redis will enable Celery to scale by acting as the central coordination point. The task queue, the logical queue managed by Redis, where pending tasks wait to be picked up by available Celery workers. It ensures reliable task delivery and handle back process when workers are busy. And the Docker, it is nothing but a containerizer, containerizes all services, the FastAPI, the Celery, Redis into isolated reproducible environment, manages networking between containers, services orchestration, and simplifies deployment across by any infrastructure. I hope this diagram will handle most of the concepts. And this is our main.py file where we have three endpoints: the root, the process data, and get status. In this project we are going to use the FastAPI, UVCon, Celery, Redis, and python.env. So this is our requirement.txt, this is our main file, main.py, and this is our Celery underscore worker.py and task.py. And in this is our Docker file, and this is our docker compose.yaml file. Our project is running and we have a read root, try it, execute, getting the response with status 200. means our request is executed and the response code is status code is 200, and the message is hello fast API is running with celery queue, and this is coming from our main.py file. Let me execute this, try it out. Let's say we have a task 2, and let me run this. As you see, I am getting the task ID with status code 200. Processing is in background, the status. This is also coming from our main.py file, the second endpoint, which will responsible the process data. And then if I go here and if I paste my task ID and if I execute this, you will see the task ID, this one, status success, process task 2 successfully. So, and this is the beauty of FastAPI Swagger documentation to test your endpoints, what you built till now. I hope this will make sense for you. If any doubt in this, please comment it, share with your friend. Thanks for watching.